Chuan-Chou Shen, also known as River, with us. River did his studies in Taiwan, then went and worked as a postdoctoral researcher in the US before moving back to Taiwan and setting up his laboratory there, where he particularly focuses on high precision uranium thorium dating and isotope work. He has collaborators all around the world. I've been lucky enough to collaborate with River as well. Hope to continue to do that in the future. And so I'm really excited to hear what River's going to talk to us about today. So he's going to specifically be talking about some speleothem work and how that's used to reconstruct the monsoon, and also some really interesting new developments there in terms of how those records can also yield information about paleomagnetic changes. So yeah, thank you very much, River, for joining us. And I'm looking forward to your talk.
Thank you for your introduction. Yeah, so I'm going to show you my slides. Michael, could you help switch that? Can you see my?
No, just you remember that green share screen button we talked about earlier?
Oh, right. Green share. Yeah. It's my first time to give a talk on Zoom. So, it works now?
Yes, and if you can start the presentation. And
so, this one is my first slide. So everybody see that?
Yeah, it works just fine.
Oh, okay, great. So hello everyone. My name is Chuan-Chou Shen. Chuan-Chou Shen here. Chuan-Chou Shen. But people call me River. It is because my second character of Chinese name is my last name here. Shen. Chuan-Chou. Chuan looks like a flowing river, right? Yes, it's a river. So people call me River. And actually, the meaning in Chinese is a sinking river on continent or on land. It means a cave, a cave. I guess it's my fate, my destiny to study in cave. Yes, I guess. Yeah. My parents must know something, must know something when I was a newborn, I guess. Okay, I got a degree from the Institute of Chemistry and not Geology. And I earned my PhD in Taiwan, and I never got educated overseas. So, the oral presentation is my weak part. So I will try my best to introduce our work to you. Yes, and so the title here is Stalagmite-inferred East Asian summer monsoon dynamics. I will talk about orbital and sub-orbital scales. And the second topic is centennial Earth magnetic reversal event. It's 98 K8. Yeah, it's my two parts. Actually, I'm going to share you the first part. First part is I would like to introduce my lab, our school first. I hope I can have more collaborative project with you together. Yes, and so this one you see this ANU here is my school logo, and our lab logo, high spec. And the speleothem is our the key material today, because ANU located in Australia. So I'm going to introduce you some slides about the Australian monsoon, the counterpart of the Asian monsoon. Okay, so let's go. The first one, I'm here in a Department of Geosciences, National Taiwan U. This is our building. Looks very beautiful, I believe. And Australia here, and Taiwan here. Our school, Taiwan U, located in Taipei, northern Taiwan. Yeah, we have a rock actually rock part in front of our building, quite pretty actually. If you come, you will like it. Yes. And here's my lab. My lab is called High Precision Mass Spectrometry and Environment Change Lab. People call it high spec. Yes. We have some clean rooms. People doing separation here and machines here. And we have people. Oh, this one's our critical things. We enjoy the of course Christmas, also the Chinese New Year. Before the Chinese New Year, we always give people the red envelope with something special inside. Yeah, and we also have a routine PVP lunch. Many labs will join together to share their studies every Tuesday. Actually, it's me. I like playing badminton. So someday, if I go to ANU, I hope I can play badminton there. Yeah, if some players there. Yeah, and so yeah, here's the key part in our lab. We use the uranium shear nuclides, uranium-238, uranium-234, thorium-230 to determine the age of rocks. Of course, our major material is coral and cave stalagmite. We use this machine called Neptune. This is our technique published in GCA in 2012. Currently, the carbonate only 1 to 100 milligram required, depends on how precision you want. Yes. Currently, the best precision, the age, the uncertainty we can get the plus minus about 3 months. Yes, it's amazing good. But depends on the sample actually. Yeah. Here's one example. We have 1, 2, 3, 4 long strong calcium record of 4 coral cores drilled from the Southwest Pacific. Strong calcium ratio can infer sea surface temperature. So this one is from 1645 to 1995. So we want to slice them together. We use the bending counts, also the high precise uranium thorium dating, and so we can combine them together to build a very solid records in South Pacific. Here's another symbol in Japan. This is stalagmites only like that small, 10 centimeter only. So the deposition rate of this stalagmite quite low. So we conducted a high resolution dating here. We can date, of course, this is about a decade ago. We can date like over 20 layers, 20 horizons with the interval of like 1 centimeter. Yes. Now we can do more now. Yes. So this is our dating. Yes. One application is this one. Yes, this one. This one is a marine coral records of the Indian Ocean dipole. Our leader is Professor Erin. She just introduced me. Here's my students and PhD involved in this project, and we helped they offer the high precise thorium edges to reconstruct this record. Yes. Yeah. Thanks, Naren, to invite us involved in this project. Yes, this one is one example. This is another one example about I believe everybody knows the 2004, the very huge earthquake around the top of the Sumatra Island here. This scale is a 9.2 earthquake, so induce a very huge, large tsunami in the Indian Ocean, and over 200,000 people killed in this event. So people will ask, when is the next huge earthquake coming in the future? So we use micro atoll. Micro atoll is actually, this one is GPS actually. When the sea level rise, the formation will change from the surface here and then coming up here. So the earthquakes here. This is a cup shape micro atoll, and this is a head shape micro atoll. Here's the earthquake. So we can use the morphology of micro atoll and also the dating technique, and so we can reconstruct the past earthquake series over hundreds of years. This is the result. The leaders, his name is Kerry Sheet, and he led this project. We worked there over 10 years, I believe. And then finally we got this figure. This one is a Sumatran Islands here, the southern part called Mandawa Islands. This one, a big earthquake occurred in 1833, the scale 9. When will be the next big ones? And based on our reconstructed history, and you can tell from the 1300 to 2000, you can tell from the north to south, we dated the corals on 3 islands. The 3 islands patterns almost the cycles almost I would say identical actually. So what we see here, we find the earthquake cluster every about 200 years. Like this one, another small one, and then end a huge one, and repeat it again, one small one, and then another one, and then here we predict if the behavior is right. We predict another earthquake cluster coming here on these islands. So this is another good news, but people should be careful there. Yeah, the clusters there coming. So this is another case in the Sumatra Islands. We reconstructed use a micro atoll. You construct the big extreme earthquake in the past over 4,000 years. So the one in 2007, the 8.1 earthquake. This one is not the biggest one. Actually, the biggest one is in the past. So, but because this one in the past 4,000 years, only 1, 2, 3, 5 times. So in the coming decades, should be okay. Should be we feel like it will be no earthquake. The next one could be in the future. Yeah, this is good news for the Solomon Islands. This one, today the example I gave you almost around the Pacific and also in Asia and also in Australia. Recently in the past years, my study area moved to the Mediterranean Sea and Africa. I'm not going to introduce that part. This one, yes, this one is the interesting part. I believe everybody go to Egypt to see the pyramids there. But do you know there's a coral pyramids in the Pacific? Do you know that? Maybe you knew that, maybe not. There's a unique truncated coral pyramids in the Pacific. It's a Coast Ray in Micronesia here. So this one, the construction of this is a reconstructed pyramid. When the pyramids constructed was a question. Then people believe this one could be constructed in the 16th century, 17th century. But after dating the corals, the material used is basalt, and also the coral boulders like this one. And Dr. Roy Richards of the Western Australian Museum, she working on top, picking some pieces there. And another collaborator from Australia is Hub, JP Hubs from the EU Queensland. And we work in a tomb actually, and pick the coral pieces, and we date it, and we find all of the pyramids in this area on this island, constructed in 14th century. This one is 1310, even 1322, even 1380 something. So so this one is the construction is about 3 centuries earlier than previously estimated. Surprised me, yes. So next one is this is a good example. We can date now. We can date a coral has an annual bending, right? But actually we can date the spatial and annual bendings right now. The corals, spatial, then some of them can deposit very fast. Very fast means 1 millimeter per year. 1 millimeter per year. We can date the single bending, annual bending, with a precision of the 5 months, 6 months. So we can test if the spatial then bendings form annually or not. Yeah, we have the idea in the past decades, but we couldn't have the good samples. We found these samples from Shenren Cave in southern China. And after dating, we found basically the bendings formed annually, but some of them are false bends, and some of bendings missing there. So if you want to use bend counting as age chronology for the spatial and age model, you should be very, very careful. Yes. Another one is that we can now, for the very small part, very, very young part, we can date it very precisely. How about the all part? All part now we can date it up to like 700,000, even 800,000. Yeah, it's not easy. Yeah, and then we publish Hai Chen, famous researcher, and Larry is I worked under him for 3 years. It's me. Yeah, and this paper published in EPSL 2013. We presented the new decay constant and new uranium thorium as a topic analytical techniques there. And of course, John Woodhead, I believe you know that, and John Hellstrom involved in this project. So under using this technique, we can date very, very old samples up to 700,000 or 800,000. Application here, we date very old flowstone. This one, where in the cave, this cave called Stima de los Jesus. I don't know how to name it in Spain. Inside in the cave, this is a very, very primitive Neanderthal in Spain. Yes. How old this one is? This one, this one is high here. This one we dated is about 850 plus minus 100,000 years, something like that. This is a limit of this uranium dating. Yeah, this one. Yes, another one is the applications that we recently in 2019 we published a paper in Nature about a 160 Ka Denisovant on Tibet. Yeah, this one this one surprised everyone. The servants first found in this one cave in Siberia. Now we can find it on very high mountain in Tibet. Yes, we date because this is a lower right jaw here, and this is a very layer of carbonate like this one, and we date them different parts and get a very consistent ages 160 Ka. Yes, we did that. So this is my map. So today I'm going to introduce to you the East Asian monsoon and also its counterpart in Australia, and also a small topic but very important about the magnetic reversal event. It's 98K. So this one is a global ITCC map. This is a boundary of July, and here there's the blue lines in January, and over the global scale, this one the boundary can move during the, we believe during the glacial time this one move a little south, and in the glacial time it's move a little north. Of course, this one is a simple one. Actually, in the ocean, this one can shift just a little bit, some degree only, not the one. Okay, so today I'm going to show you our studies around this area in East Asia and also the Papua New Guinea. Yes, and also one slide with South American monsoon here. Now many labs in the world use spatial to reconstruct the hydroclimate conditions in the past on different time scales. I believe this is a very early and important paper published 2 decades ago in Science by Wang Yongjing et al. Yongjing Wang is this guy. I was very young decades ago. Yes, and this one is a cave, Hulu Cave. Now is a tour cave open for people. If you pay the ticket, and you can go. Yes, and Dr. Wang used some stalagmite collected from Hulu Cave to reconstruct this one. This one is oxygen, space-filled oxygen, stalagmite oxygen records from 10K, 10,000 to 75, 76K, and pink one, green one, red one means present the different stalagmites. And so the values from -8 to -4, and negative, positive, and then up and down. So in this study, we find basically for orbital scale, this a long-term change follow this line. This line is the installation curve in the north hemisphere. So because monsoon basically is a temperature contract between land and ocean. So follow these installation lines. It makes sense. Yes, and in the records we also find millennial oscillations here, and then this one can match to the events in the North Atlantic high latitude in recorded in Greenland ice cores, and so overall we believe the monsoon in Asia controlled by 2 factors. One is installation, another one is from the Atlantic high latitude. Yes, by the tail connections. This is the first study. So follow up over thousands of paper published using the stalagmite. Yeah. Next, one published another paper in 2008, and then the record extended to 2020K. 2020K using the deep stalagmite oxygen records from different caves in China, including the Sanbao, Dongge, Hulu, and others. And then we can the colorful records is reconstruct Asian summer monsoon. Basically, this record still follow the gray line here. The gray line is, again, this one is installation curve in the north hemisphere. Basically, this one is dominated by the precessional cycle, which means 22, 23 thousand years the cycle is. So this is 2008 extended record to 220 Ka. The reconstructed the East Asian monsoon history. So this is in China, Chinese records. How about others? Here, I would like to move to the South American records. In Brazil, done by this smart guy called Xianfeng Wang. Now he is a professor in Nanyang Tech University in Singapore, and he went to Brazil, Amazons, collected samples back to lab and date them, and we find the formation of the stalagmite only on specific windows with a high insolation in southern hemisphere. So it makes sense. It makes sense because it is here. So it's a boundary of the ITCC is sensitive. It's sensitive to the rainfall belt. And so and the follow-up studies is here. Oh, I didn't show you there. So basically, when on orbital scale, during the glacial time, ITCC shifts to the south, and this South American monsoon enhanced, and so increased the rainfall here, shift ITCC a little south. So the stalagmite formed, and we detected here. During the interglacial, ITCC shifts north, so this is dry around here, but the monsoon here is strong. So the question here, so we see the anti-phasing between the north hemisphere and south hemisphere tropical zones between the monsoon system. So how about the Australian monsoon? So we went to the Papua New Guinea here. There's a coastal zone which we call here, called the MD052925. And eventually, we published a paper in 2015 by my PhD student. Now they are now, yes, and we wanted to reconstruct the rainfall history in Papua New Guinea to find the ITCC around this southern hemisphere. So our tour, this is our core here. Asia monsoon records from the caves is here. And our tour is a 2 box. This is a planktonic-foreign. This is a benthic foreign. Benthic foreign for the H model. Planktonic-foreign is our. We analyze the rare earth elements in this box to get the rainfall history in PNG. How about the fundamental theory? Because rare earth elements, REE in ocean, surface ocean, actually the concentration very, very low, only picogram per gram, actually very low, almost none. But in the rivers, the concentration is about 30 to 50 nanogram per gram, very, very high. So over 10,000 times high. So when PNG got the heavy rainfall, and the RE elements will be dissolved in the fresh water by weathering process and delivered to the coastal zone and recorded in the planetary foreign. So we use planetary foreign RE to get the rainfall history in PNG, but RE in foreign box is very, very low, only nanogram around nano per mole. It's quite low, and the analytical technique in the past, people should use a time-consuming chemistry to separate purified REE from carbonate and then run it in the machine. So in 2011, we developed a very fast technique. We just dissolved the cleaned foreigns about 10 to 20 microgram, enough, without separation step, and then we can run sample about 8 to 10 samples per hour. 8 to 10 samples in the past, people should do it in 1 week. Now it's 1 hour, so totally changed. So we use this machine, element 2, to get that. And this is our methodology. And your professor Jimmy Yu here, yeah, he was involved in this project. And then, by the way, I would like to introduce. We developed many different techniques, isotopes techniques like uranium, different uranium thoriums with sulfur isotopes and others. And we also developed elemental technique for elemental calcium ratios in carbonates. So if you want to do something, I'm happy. I will be happy to collaborate with you together. And then, so REE, this one, REE is here. So this one's called a spider diagram. A spider diagram here. This one is an open ocean pattern. Open ocean pattern, but the PNG foreigns, the core here, we got the pattern line. This one completely different from the open ocean one, because this one we got the input from a river. So this pattern is a mixture with open ocean and the river, two sources. So we got this one, and then of course we check the isotopic signature. This one from the low REE level and high REE level, the neodymium, epsilon neodymium, the value always -1. This values is a match the terrestrial part on PNG. So this one, even the low REE or REE, only one single dominant source from the terrestrial input by the precipitation dependent river runoff. So REE calcium ratios, or we simplify it to neodymium calcium ratio, can be used to get the PNG precipitation history in the past. So this one is our result. This one is the PNG precipitation here, from 0 to 280K. And then the low up and low up like that. And this one is a Chinese cave oscillation record inferred Asia summer monsoon intensity. This one high Asia monsoon, low Asia monsoon, and blah, 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 and then down again and up again like that. At the very beginning, we analyzed the first 50K here. And then this one is perfect. When the Asian monsoon is strong, the southern counterpart is weak. When Asian monsoon is weak, the southern part Asian Australian monsoon here is very strong. Yes. So for this one, basically follow the pattern we just find in the South America. So this one is a North Hemisphere, this South Hemisphere. They basically are anti-phasing relationship. So years ago, we intended to publish paper first, and then but we decided not to do that. We wanted to extend the record longer, and then to see this anti-phasing relationship is still sound or not in the past. So we did that, and then we find some window periods not, because like this one, the Asian monsoon week, we should expect to have a peak here, but it's gone. It's gone. And how about here? This is a weak Asian monsoon, and we supposed to have one peak here, but this one is depressed. I would say that. And this is another example. This is a low Asian monsoon, but the Australian monsoon. I mean the rainfall in the PNG not clear. What happened there? So we find the disagreement windows here occurred during the high abruptity. Even the oscillation, the insulation in southern hemisphere high, but during the high abruptity, the PNG precipitation looks like muted or decreased. There, what's going on there? And we check that. We do the spatial analysis, and we find here the PNG rainfall records here. We got a strong abruptity band, which is a 41K, and of course this is a precisional band. This is normal one, but this is a strong one. So even this system, the Asian monsoon, Australian monsoon here in south, in north, this is 33K precision, forcing dominant, and this one's not a story. I totally surprised us. And so we did the symbol transient model. These are blue lines our records, and we did the symbol models. Somewhere the sector somewhere here. Anyway, this modeled PNG rainfall records looks very similar, right? Almost identical, I would say that. Even we just use the very simple transient model, but here is the reconstructed North Australia rainfall records, and here when it's muted here, we should have a key peak, but no. But here North Australia, a huge rainfall here, and this one is the same case. So this one we should have a peak here, but no. The peak shift to south to the North Australia, and recorded to the lake water level. Here's a water level, high water level here. It's 50 and also 100K with a high abruptity. Yes. So we believe the two orbital forcing on the PNG rainfall. Two orbital forces. One is a precessional forcing. Everybody knows that the land and ocean, the temperature gradient. Another one is from high Siberian high, because 41K when the Earth tilted a little bit, the Siberia high will be extremely cold. When the winter monsoon, the boreal winter monsoon, a strong winter monsoon flow from the Siberia to south, and then there's a close equator flow and push the south ITCZ is south, and then move the ITCZ from the boundary here to the south here. Yes, so recorded. So we got rainbow, huge rainbow in the North Australia. Yes, this is our findings. So recently, so here, how about the future? Because we find about this one is our records. We find the precessional cycle. We also find a strong abortic cycle. How about the future? We are sending the records from 0 to 280K. Now we send it to 800K. Maybe I can show you next time and next year. And we also want to extend the record to the million years to see what happened about the rainfall history in the PNG. Yes. And recently by the Dr. Dacre and his colleague published a paper 2017 using the sediment Newtonian epsilon Newtonian records in of the South Australia. This one, the records here. This one means high rainfall around the Central Australia delivered to this ocean. So this one, and then the blue one is our records. Looks like those are very similar, or even very close. Even one is here, another one is here. So yes, this is even on the sub-orbital scale. This is on orbital scale. In this finding, they find the high ridge event originating from the North Atlantic high latitude. Due to the fresh water input, and then slow down the AMAC flow, global circulation flow, and this forcing can even affect the hydroclimate condition in Central Australia. Yeah. So now. High chain, Larry, and they extend the records up to 640K. 640K. So basically, this one, the green lines segment records, basically again follow the installation, yeah, which is precessional portion dominate, but they also find a weak abortic portion here. So, but in this paper they argued the 100K equations. Yeah, 100K equations. They say that the 100K actually is here, and average of the discrete numbers of precession cycles. And here's the 5 cycles, and these are 4 cycles. And these are 5 cycles, these are 5 cycles. So basically, he's a 100K records in marine records actually is from 4 or 5 precession cycles. Why? Because marine records could not be dated precisely. Currently, no any absolute chronology for marine records. So marine record basically lets you tune to the installation. Yeah. But looks like there's a debate. Looks like Asian monsoon record inferred stalagmites perfectly follow the basically follow the precessional cycles. But the debate, check these records. These records the red line from 0 to 550K. This record is the Barrier 10 records. From where? From here. Baoji. This is the Chinese noise plateau site. Warren Beck and his colleagues reconstruct the rainfall in this area. This one, basically the rainfall inferred from those Barren 10 records. This one, you can tell, this one clearly match the blue lines, And blue line, what's blue lines? Blue lines, this one, blue line is a relative sea level or the ice volume change. This one is a strong 100K cycles here. So now we have a dilemma here. So in the lowest Barren 10 get a strong 100K records on the monsoon intensity and also rainfall history in this North Chinese lowest area. But in the segment, we got the 23K. What happened before? What happened between the two records? People still working on that, but one possibility is because of this is a lowest site. It also experiences a strong westerly from the west. This one possible explanation. Yeah. So another study is by the Oxford group. They found the formation of speleothem in a lake Baikal in Siberia. Yeah, they find that basically the speleothem deposit only on the very warm conditions. Yes, and this study apparently favor the lowest Barren 10 records here. So this one's still a debate debate between the segment record and others. So here I have no time to go through the very detail about the sub-orbital scales, but basically if you high chain summarize all Chinese segment paleoclimatic records in 2019 in this paper, basically here for the sub-orbital scale, two portions. This one here is a sort of Malayan scale from the north, recorded in Greenland ice core, and also from the south, from Southern Ocean. Yes, you can tell this one. I couldn't see it. This one, the data D records in Antarctica reflect the Southern Ocean temperature. So actually, the cave records in East Asia control. I mean, some orbital scale controlled by two factors. One is from the North Hemisphere high latitudes, and one is from Southern Ocean. Yes, and also another debate about the segment oxygen records. What's that mean? This one mean rainfall or intensity? After 15 years study, people believe only in the northern China, this one segment oxygen record can reflect rainfall, and south and central China, because the hydrological condition is quite complicated, the oxygen records cannot reflect the local rainfall, but can show the monsoon intensity. Yeah, after working 20 years. This one is example from Dong et al. This one in review. We use a segment in northern China. We find that this is a duplicate of the segment from two caves. One is LH and one is LD. The different color means a different segment. They match each other very, very perfectly. Yeah. So, and also agree with this one. This one is a reconstructed quantitative rain precipitation history. So they match very, very well. Yes. So this is a but actually the stalagmite oxygen records quite complicated. This is our records here. But can we reflect to the source? How about the source? The source from the Indian Ocean or Australian Ocean? Also, it's now currently is debate. The source, we should figure out the source. And the source, we got precipitation, and precipitation oxygen can be recorded in the drip water data auditing. They consistent or not? Here I give you two examples. One is the LO in Furong Cave in Chongqing, South Central China. Here we monitored the cave now it's over decades. Basically the result same. Here the drip water data auditing records the dots here, and this line, this one is the weighted annual mean of the rainfall record outside. So they match each other. It means that the drip water in Furong Cave can reflect the precipitation data auditing value in this cave. I mean the annual weighted data auditing records. But here another cave in here, this one is called Fujian province. This cave is the Xiangyang cave. We find not clear here, but basically the drip water data auditing value, this one here, and the precipitation rainfall oxygen data auditing records is here, but the average weighted average this one, and the cave drip water always below divided than the rainfall values. So basically, this one reflects only summer rainfall amount instead of annual mean, and because of evaporation effect here is quite strong. So based on these two study in the two caves, we would say that case by case, if the evaporation is strong, this one the cave drip water basically reflect the summer rainfall. But for the area without a strong evaporation effect, they reflect the annual mean. So this is another one. Let's skip this one. So here the observation in the two caves, we can tell precipitation data auditing can completely recorded in drip water data auditing. The answer is that depends, is a site specific dependent, not completely right. But can Chinese record stalagmite record can reflect the monsoon intensity? The answer is yes. So I just finished the orbital forcing orbital Asian monsoon records, and also I talked about the Australian part, its counterpart. The orbital forcing quite different. One is in the North Asia is a precessional cycle dominant, but in the South it's not. It's both precessional or also the abruptity. So the next one is I would say this one is a centennial Earth magnetic reversal event at 98K. This study is the most important scientific findings in my entire career so far. Yeah, I'll say that. Here is our magnetic North Pole drifting from the North Canada, just placing the geographic north, now heading to Asia. If this one, the pattern is right, in 15 years, the north, the magnetic North Pole will reach the southern Siberia. So it is impending reversal going to occur in the coming future decades? This is an open question. Yes, about how fast this reversal can do. Yeah, how fast the reversal can flit from the north and then south. This is an example. People said people find the European researcher find a sediment, a very old lake sediment on land. They find during the MB boundary. This one's a very famous magnetic reversal event. It's 89K. So they find from the rock. They find the reversal is very fast. It's only 100 years. Only 100 years. They published one in 2014, and then this record surprised everyone. And then this is very fast. But the follow-up study in 2018 on the same site, same material, they find this reversal event in the sediment is completely it's fake. It's caused by the post-depositional physical chemical alteration. So the signal has been altered through time. So this is not true. So we try to use stalagmite to get the magnetic records in the past. But this stalagmite has some advantage because these are continual growth. But disadvantage is that this one only a tiny detritus inside, almost no any magnetic minerals inside. So you should survey and keep surveying around between caves to find the stalagmite with abundant magnetite, and so you can get the Earth's magnetic history in the past. So it takes time because it's not easy to find a sample. So this one is our team. Andrew Roberts here. He's a key guy from your school. This is our paleomagnetism team. We survey the caves and try to find samples. Not easy though. We survey caves around the different continents, from Africa, Asia, anywhere, and Europe. This one is in Europe. And eventually, we find a sample from southern China called a Sanxin Cave. This one, we find this one is the sample. You see, this segment from top height is here, and then the bottom. This is about from top to bottom is 1 meter long. It's quite good, and the color here is not white. This is with a high iron concentration, and we check that one. This one, the enough magnetite inside, the amount of magnetite inside, and this one also has a high uranium concentration, so we can date it very precisely, and also get the signal of the magnetic signal. But even so, it's quite challenging actually. Yeah. So here we measure the minerals in our synchrotron center. Synchrotron center, and we find the micro scale magnetite inside, a very tiny amount, but it could be enough. Yes, it could be enough. But even the signal there, but actually the signal, the magnetic signals is very weak. Only 1 million times less than the igneous rock. So you can tell the signal is so small, so weak in stalagmite. Fortunately, some machines very powerful can check the signals, and we use a rapid machine in Beijing, and the signal in the stalagmites is a 10⁻⁷, and this machine, the background 2 plus minus 10 EMU. I have no idea about this one, but basically our signal is about 1,000 times higher than the background, so we can get the records. But you want to check that there's a centennial reversal event. If there's a centennial reversal event, your dating should over very precise ages. But our sample is from 100K. 100K is 100,000 years ago. So we do the test and you duplicate. The duplicate is quite consistent. The two measurements, the age always the same. And the error bar here is only tens of years for the age, for the civilian with the age of 100,000 years, with a precision the tens of years. So it's enough. So this is our result. Our result from here is 107K to 91K. So we got a records here, records here. This is in incarnation. Basically, the typical ones is this one from north to south, very fast, and then bounce back slowly back. And this is a symmetric oscillation. From north to south very fast, but bounce back to the equator and then slowly back. Yeah, this is about 1 to 2 millions, 1 to 2,000 years, and then here some oscillations is several hundred years, but basically the record is the same like that. And this one, this symbol is with a weak earthquake magnet intensity, so easy to have a reversal here. But this one, we enlarge this one. This one is the reversal from 98,360 to 98,216. So this is 144 plus minus 58 years from north to south. So this reverse, if considering the arrow, this one can occur within 100 years. So this is a reconstructed path from north to south. That's about 100 something years. So in this study, I would say this is my best study in the past 20 years. We find hundreds to thousands asymmetric oscillation. Now we call it Zhou oscillation. And another one is abrupt centennial reversal at 98K. So what's the next? So after reporting this study, a lot of the media gave the report. So the unknown, we saw this one. So the very detailed structure is the first time revealed. So what's the main unknowns? One is the mechanism for this one, asymmetric oscillation, and then this one special case for this time window or common feature everywhere, and this one 100 years reversal events. Any reversal event sooner than this one or not? We are working on this, the three unknowns, and I will tell you next time. Yes. We got the records already, so I'll tell you next time. Oh, so here's my last slide in this talk. Thank you for inviting me here. In this talk, I introduce my lab to you, and also Stalagmite-inferred East Asian summer monsoon, and also his counterpart in Australia, and the third part is the centennial earthquake magnetic reversal at 89K. So this is my talk. Thank you very much. Yeah. Oh, this I talked over 1 hour here. 1 hour. Sorry about that. Yes. Any questions?
Yeah. Do you have any questions for anyone?
Thanks very much, River. I might start with a question if that's okay. Yeah, so yeah, thanks. So there's a lot of material in that talk, and fascinating stuff. So I've got one question about the magnetic reversals there. So there was a paper, I think in Science, might have even been earlier this year, talking about the potential for a magnetic reversal at 41,000 years, and speculating that that had produced a large climate effect. I was just wondering if that's a signal that you've looked for in any of the speleothem records, because I guess that would be a nice way of testing sort of the relative timing of that compared to the climate changes.
Yeah. For 41K, the event and related to the environment change. Yeah, we actually in our new records we also see that, and we also find this climate relationship there. And actually we extend our records not just one event. We have the entire time series, but I couldn't show you here right now. But yes, I would say that the magnetic reversal or excursion event strong affected by internal forces. Yeah, I should say that sub here, and we are preparing the papers. So I will tell you more details in months. Yeah, for sure. Yes, it's right.
Look forward to seeing that. Yeah.
Yeah. And any questions from? Sorry, I gave you many material because this is my first time to give a talk here. I would like to introduce my lab to you. Next time I will focus on just one topic. Yeah, next time. Any more questions?
I might ask another one if that's okay.
Yes.
Yeah, no, I was also fascinated by the 4M records with the rare earth elements.
Right.
And the laboratory advance there to be able to do those analyses so quickly is quite amazing. I was just wondering, is that a type of proxy that would work for any sediment core close to a river, or are there any sort of particular conditions beyond just being near a river that you need for that proxy to work?
Yes, you that's a very good question. And this one originally this one the REE content in forums used for reconstruct the intermediate water of deep sea water circulation in the Atlantic, because in the deep sea water the nodule oxides could form on the surface of the surface of the box. So this one with the very high RE levels in the deep sea. So REE can reflect the intermediate water or deep sea water conditions. But here is quite in Pacific, especially in this side, is completely different. We just focus on one side. I believe this application can be applied to other sites with no any formation of the oxide nodule on the surface. Yes, this is can apply to other area, I believe, in Pacific. in Atlantic, quite completely different. Yeah, because a lot of material formed outside by your eye, you can tell the very black dots on surface. This is a formation of the oxide. Yes, so it's different oceans. The REE inference can be applied for different topics. Yeah, for sure. Yeah, and now actually we we use RE in corals actually, and now people use corals annual RE content, but using our technique, we can do a monthly or actually weekly resolution, and we see the seasonal input from river water, but we did not publish yet. We still working on that by my students. Yeah, corals.
Again, yeah, no, that sounds fascinating.
Yes. Any questions? More questions? How about Michael? Do we have one?
No, I don't have any. Thanks.
Okay.
Yeah. Well, I think we can finish now. And if anyone has more questions, they can contact you by email or anything, I guess. Okay. So,
okay. Thank you, everyone.
Thank you so much for this, and good luck.
Hopefully, I can visit your school very soon in the near future, maybe next year, for my sabbatical, actually. Okay, thank you.
Great to see you here, River. Thanks for the talk.
See you next time.